Hello, in today's lecture, we are going to learn how to apply laws of indices in some expression involving algebra. Supposing we have a raised to power 3 times a squared, this can be written as a raised to power 3 plus 2, okay, because we have multiplication at this point, and therefore here should be addition if you observe what is going on. So this will give us a raised to power 5. But one can like to verify this result. I may decide to verify this result. So I can check that this is true. For instance, let's do a check. I can say that a raised to power 3 is nothing else but a times a times a. Okay. Then I will also find out that a squared is the same thing as a times a. Therefore, when we have a raised to power 3 times a squared, this is nothing else but saying a times a times a. That's this first part. So I've taken this part. Now say times the second part, a times a. Okay, what do you observe? So we count how many a's do we have. This is 1, so we have 1, 2, 3, 4, 5. So this will give us a raised to power 5, and that agrees with the result we have already gotten here by applying the law of indices. So we can verify that this is true. We can look at another example. Supposing I have b raised to power 5, okay, divided by b raised to power 3. Again, by the law of indices, we observe that these have a common base. So we have a common base here. This is b, this is b. So we pull out the common base, and that will give us b raised to power 5 minus 3. We're having minus at this point because we have division here. So we have already know that by the law of indices. So that will give us b raised to power 2. So as we did in the previous example, I might decide to do a check to see that this is true. So how do we do that? We recall that b raised to power 5 is the same thing as b times b times b times b times b, okay? Then what of b raised to power 3, or b cubed, okay, is the same thing as multiplying b by itself 3 times. So this is repeated multiplication of b by itself into 3 places times b times b. So we see that b raised to power 5 divided by b cubed, okay, can be written as b times b times b, okay, times b times b, now being divided by the second b here. So this is b times b times b, and our common arithmetic, we can know that we can cancel this. So this b cancel b, this b cancel b, so this b, we cancel this b. How many b's are left? We are left with only 2 b's, which is now b times b, which will give us b raised to power 2, or b squared, okay? And that agrees with the result we have gotten here. So this is the same with what we have here, and this is the same with what we have here. So we verify that this is true, but we don't need to be repeating this in the subsequent example, but we just want to show this to indicate that our results we get in the law of indices are correct. So we want to evaluate this multiplication. So we have 2 times x raised to power 5 now being multiplied by 5x cubed. Okay, so if we look at this, first of all, we can decide to handle the numerical and see that this thing is the same. So we look at the 2. This is 2, first of all, 2 times 5. So we write this out. 2 times 5 will give us 10. Good. Now, we go back and observe that we have a common base in terms of the variable x. So the variable are given in x, so we have x raised to power 5, and here we have x cubed. So because the x are common, so the common base is x, so we pull out the x, okay, in this form. And again, we observe we have a multiplication here. We have a multiplication. Because we have a multiplication, then we have to involve addition in the index. So this will give us 5, okay, plus 3, and we'll return this as 10x, okay, raised to power 8. So we can look at another example. Supposing we have, let's have a division now. Supposing we have 12x raised to power 8, okay, divided by 4x cubed. Again, we'll see that we have numerical values here. So we first of all do the division. So the 4 will divide itself, that will give us 1, and 4 will divide 12, and that will give us 3. So we first of all pull out the result of that numerical division. So this will give us 3. Okay? Now, we recall that we are now left with x at the denominator, and we have x raised to power 8 at the numerator. Because they are involving division, so the law of indices will also apply, as we know. So this will now give us x. X is the common base, and this division we have at this point becomes minus. So we now have x raised to power 8 minus 3. Okay, so this will give us 3x raised to power 5, because 8 minus 3 is 5. So we can look at another example. Supposing we have this as an example. We have 2. So we have 2x squared times y cubed. So you observe in this case, we want to look at example involving two variables. So these two variables in terms of x and y, so times 3x raised to power 5, okay, times y. So how do we handle this? Again, we first of all handle the numerical value. So we have 2 here multiplying 3. So we first of all do that numerical multiplication. 2 times 3 will give us 6. That's good. Now we go back to the other variable. So we have the variable given in terms of x here. So at this point we have x squared. Here we have x raised to power 5. So they have a common base, and we pull them out. So we have x here. Now because this involves multiplication, so we are going to add. So we have this index here 2 and another index here 5. So we add the indices. So that will give us now 2 plus 3. Okay, 2 plus 3. So we are done with the x. So we go back to y. So we go back to the variable y. So the variable y, here we have y cubed. Here we have y raised to power 1. Here is raised to power 1. Even if it is not indicated, we know it is power 1. So we involve our y here. So we write the variable that is common, which is y. So again, it is multiplication. So this will now give us 3 plus 1. So we return this as equals to 6x raised to power 5, because 2 plus 3 will give us 5. So this will give us raised to power 5. Then again, to the variable y, 3 plus 1 will give us 4. So we write y raised to power 4. So that will be the simplification of that problem. Okay, so let's look at another example. Supposing we have something of this nature. Let's look at something involving division. So we have 12x raised to power 8 times y raised to power 5 divided by 4x cubed times y squared. Okay, again, we look at that division. We handle the numerical division first. So 4 can divide 12. So when 4 divides itself, we have 1. So when it divides 12, that will give us 3. So we have 3 over 1, and 3 over 1 is equals to 3. So we pull it out. Now we observe the two variables involved, x and y. So we have x here, we have x here. So we pull it out because it's common. So we have x, okay? Now we go back to the indices. We have x raised to power 8, so the power here is 8. Here the power here is cube. And we observe that this involves division. Because it involves division, we are going to subtract the indices. So that will give us x raised to power 8 minus 3. So we are not done with the case of the variable x. So we go to the variable y. So we have y here, okay, and we have y here. So this is y raised to power 5. So we first of all pull out y. So this is times y. And the power of the y in the numerator is 5. Again, this involves division. So we are going to subtract. So we subtract the indices of the variable in the denominator. So that becomes 5 minus 2. So this will give us now 3x, okay, raised to power 8 minus 3 is 5, okay, times y. 5, this is 5 minus 2, which will give us 3, okay. So we have 3 at that point. So that will give us the simplification of that problem. So maybe we round up with another example. So supposing we have something of this nature now. So we are given 2y times 3y. Now this is all raised to power minus 2. So how do we handle this kind of problem? So we involve a lot of indices here. There is a lot of indices we are going to apply. Recall that when we have, supposing we have something like x raised to power minus 2, this is equals to 1 over x squared. Okay, so that law will apply in this problem. We write this now. So 2y times 3y all raised to power minus 2 will be equals to 2y, okay, times 1 over 3y raised to power 2. So the minus has gone, so we are taking the inverse now. Okay, so when we do that, that will give us, we see the numerator 2y times 1 will give us 2y now over 3y all raised to power 2. Good. So what follows now, we can do this expansion in the denominator. So we have 2y, okay, over, in doing this expansion, so we see that this is 3 times 3, okay. So this place will give us 3 times 3. Now what of the y? So y is y times y, because we have y multiplying itself over, okay. So this will give us now 2y, as we have done before. If you want, we can do the cancellation and we see, like we did previously, we can see that one of this y can cancel one of this y. So we are now left with only one y in the denominator, while we are left with 2 at the numerator. So this gives us 2 over 3 times 3 will give us 9, okay, and multiplied by y, which will give us 9y. So when we do that expression, we have 2 divided by 9y.